Have you ever had a complex, hours-long conversation with an AI, only to realize the next day that it completely forgot who you are and what you were working on? Large language models, or LLMs, the core algorithms powering modern AI chatbots, suffer from severe amnesia. They cannot retain memory across different sessions. To bypass this limitation, developers typically force one of two blunt workarounds. They either ruthlessly chop off the oldest parts of your conversation to make room for new text, or they take every single past interaction and dump it wholesale into the current prompt. Look at this line graph plotting token volume against processing time. Tokens are the basic fragments of text, like syllables or words, that an AI processes. As you dump more historical tokens into the prompt, the processing time forms a sharp exponential curve. Eventually, it crashes into a hard horizontal barrier. That barrier is the model's maximum context limit. Long before you hit that wall, the sheer volume of data chokes the system, pushing response delays well past 500 milliseconds. We are left with a massive design flaw. An AI requires deep, persistent context to actually understand your specific problems. But forcing it to remember every detail using these brute force methods destroys its ability to generate responses quickly. Overcoming context collapse requires us to stop treating memory as an endless timeline. The solution is abandoning linear history for a multi-tiered architectural structure. Instead of a flat chronological list, we can map out a multi-agent memory management system. Think of this as a physical three-tiered spatial hierarchy, where different types of memories live at different depths. Watch how this top platform assembles itself. This is the active surface layer, known as hot context. It holds the last few turns of your conversation in high fidelity. Because the data sits right at the surface, the AI instantly recalls it for immediate responses. Now look at the second platform sliding into place beneath it. This is the summary layer. It acts as an automated threshold. When the hot context layer gets too crowded, the summary layer pulls down the older active thoughts and compresses them into a condensed summary. This auto-consolidation guarantees the top layer never overflows. Finally, the deep foundation block locking into place at the bottom is cold storage. Here, older inactive messages are permanently archived as vector embeddings. Vector embeddings are numerical representations of text that capture the underlying meaning of words rather than exact phrasing. These embeddings are stored using ChromaDB, an open-source database optimized for finding similar vectors instantly. By stacking memory vertically, the system safely tucks away a massive historical archive. The AI's immediate processing window stays light and fast, no matter how much data you accumulate over time. A developer cannot manually drag and drop data between these three layers during a fast-paced coding session. Navigating this structure requires an automated internal workforce. That workforce consists of three autonomous agents operating entirely in the background: a storage agent writing the data, a consolidation agent summarizing it, and a retrieval agent returning it. The retrieval agent manages this through semantic search. Instead of blindly grabbing whatever was said 5 minutes ago, it analyzes the meaning of your current prompt and dives into cold storage to find historical data that matches your current intent, even if the information is weeks old. Together, these three agents function as the AI's subconscious. They quietly organize, file, and fetch your past knowledge, so it surfaces exactly when you need it, completely invisibly. We can take this abstract architecture out of theory and plug it directly into a developer's daily workflow using tools like the Neo extension for Visual Studio Code. Once installed, Neo reads your open files and executes terminal commands right in your editor. And because it runs on this memory system, it remembers the specific design decisions and bug fixes you discussed regarding your codebase across multiple sessions. There is a crucial security advantage to this setup. The entire memory architecture, including the vector database ChromaDB and a standard SQL database, operates completely on your local machine. SQLite is a lightweight, file-based database that stores data directly on your hard drive without needing a separate server. Because there is zero dependency on external cloud storage, your proprietary code and sensitive project histories never leave your internal workspace. No data is sent to a third-party server for long-term archiving. For teams handling secure information, true enterprise-grade AI utility requires absolute data sovereignty. keeping all processing local is a strict operational requirement, not an optional perk. We noted earlier that forcing an AI to remember more usually means slowing it down. This tiered architecture actively reverses that memory penalty. Look at this comparative bar chart detailing token consumption. The towering bar on the left shows the bloated token usage of a traditional memory dump. Next to it, the dramatically reduced bar reflects the multi-agent system. By smartly pruning and tiering the data, this method cuts token usage by 35 to 45% during long sessions. Now watch the metrics shift to latency measurements. While a standard heavy prompt struggles with delays over 500 milliseconds, the retrieval agent's localized semantic search drops that latency down to a stabilized zone between 80 and 96 milliseconds. Structuring memory properly solves the amnesia problem, while simultaneously slashing operational costs and dramatically increasing processing speed. Consistent memory changes how we work with these models. When an AI retains your previous logic, the interaction evolves into a stable, ongoing partnership. Without memory, an AI functions as a transient, single-use tool, requiring you to re-explain your work every single time. By adding persistent memory, it becomes a continuous intellectual partner whose understanding compounds over time. In practical terms, you can pause a highly complex, multi-day engineering task on a Friday afternoon, close your laptop, and resume it the following Tuesday. The system picks up right where you left off, with zero loss of context. An artificial intelligence can only ever be as capable as the limits of its memory retention allow it to be. If it cannot remember, it cannot truly assist. Solving the amnesia problem allows a model to move past simple text generation and handle sustained development. A structured, persistent memory system is the prerequisite for any AI to maintain context over the lifecycle of a professional project.